guys, here we are live. I hope so that we are live. Yes, we are live. So, I hope so that guys I'm audible. It has been so long, 2-3 days I was not well, so I was not keeping well. So for that reason I was not able to continue the live sessions, but I will try my best to continue these live sessions and will complete our course. Alright guys. Well, first of all, welcome back to Coders Arcade guys. This is Ashank David, and in this live session, welcome back to our live session where we are doing data structures and algorithms for placement series. This is our placement series live series that we are doing, and in this we have done a lot of things. So if you haven't watched our previous videos, our previous live sessions yet, we have already created the playlist for this. These live sessions are already recorded and all the previous live sessions have been put up in the playlist where you can see all the previous videos. So go ahead and watch those videos, or if you are a new viewer here, please do like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon also so that you won't miss any future updates guys. Apart from that, share this live stream as much as possible guys, so that this live stream can reach those people who really want to learn DSA and all for free. We are going to start our class now guys. I hope so that this is very much clear. I hope so that I am also audible, and I hope so that this is very much clear. My screen is also properly visible. Backside I hope so that it is visible clearly. We will start the session right away guys. Without any further ado, let's get right into the concept. Alright guys. So what did we do in the last class guys? In the last session, in the last class, we have done graphs. So what we have done? We have done graphs. And in graphs, we have done the introduction part is done. What all things we have covered? The introduction part is done. We have covered the types and everything about it, types. We have talked about the graph representation. And what we are going to learn today is going to be, today we are going to learn about traversal. What we are going to talk about? Traversal. We are going to talk about graph traversal. Guys, if you haven't watched our previous trees live sessions, I recommend you to go ahead and watch those live sessions also. And because from this concept which I am showing you in today's class is very similar to the trees concept, the trees graphs concept. So you guys can relate with that video a lot. So guys, let us see. Just like trees, graphs also has two types of traversals. One is BFS, and another is DFS. BFS stands for breadth first search, and DFS stands for depth first search. Depth first search. Okay. BFS stands for breadth first search, DFS stands for breadth first search. If you have any doubts, I can see your live chats right in front of me. If you have any doubts, you can go ahead and ask me any doubts, and I'll be there to clear all your doubts. Okay guys, let's move on. Imagine that we have a graph. Today we will discuss actually about BFS. Okay. Now if you go ahead, go like little bit, if you go back a little bit and if you open our trees concepts, there we have understood that whenever a tree is traveled in some particular direction, for example, let's say this is our tree, and if you want to travel in DFS, depth first search, we were going in depth wise. in particular depths of the program, like the depth of the tree. But if we do BFS, if we do BFS, then BFS means horizontal traversal, horizontal traversal. So horizontal traversal we were doing, and in breadth wise, breadth first search means breadth wise, depth first search means depth wise. So in breadth first search, the data was printed right like this, in this horizontal way. But in DFS, the data is going to be printed in depth wise. In DFS, we also have learnt about in order, pre-order and post-order, okay, like that. I hope so that this is very much clear to all of you. But we are going to talk about graphs. So let us say, imagine you have a graph right here, okay, you have a graph right here. I am creating a graph something like this. Let us say this is our graph. This is 1, 2, 3, 4, this is, let's say, 0. Imagine this is our graph. This is our graph. In this graph, I want to now apply BFS, breadth first search. How will I apply breadth first search? To apply breadth first search, we are going to be applying BFS. What we will do here? We can start from any point, guys. First of all, let us talk, before I go ahead into this, let us talk about the requirements of this. Let us talk about the requirement of this. The requirements, the things that you will be required to apply BFS onto this particular graph is going to, there are some few things that you need. The very first thing is that you will be requiring an adjacency list. So I will say ADJ list. Okay, ADJ list. I will require adjacency list. Next, number 2, I will require the Q data structure. Why? You will get to know why. Achha, you remember, guys, that when we were doing the BFS in trees also, there also we have used Qs to solve problem on traversal in your trees, if you remember that. So if you remember that, we have done that there very long back. I guess it was session number, I guess 20 something it was. Okay, we will see that later on. So Qs are going to be get applied into the concept of this. So if I want to do breadth first search traversal and I want to print the answer in the graph, I would require the Q. Okay. Then the third thing that we are gonna do is we need a visited vector. We need a visited vector. If you don't know visited vector, you can use an array. I have, by the way, created the class. I have done a live session on vector also. So if you have any doubts, go ahead and watch session number 31. Session number 31. There I have explained to you what are vectors and how vectors can be used in order to do dynamic arrays. 1 minute, guys. My camera will get shut down. So I'll be pressing that button. All right. Yeah. All right. Okay. So in here we have adjacency list, Qs and visited vector. If you are not comfortable with vectors, you can go ahead with arrays. But for if you are getting a confusion with vectors, I have created the live session. Already I have recorded the live session and I have posted that into our same playlist. Session number 31, if you go ahead and watch, you will find that there. Okay. So visited vector we will be creating, it is going to be an array, that's it. Okay. Then we will be doing answer vector. We will require our answer vector. Answer vector or answer array, whatever you would like to say. That's it. These are the 4 basic requirements that we need in order to solve this problem. Okay, guys, let us try to solve this problem now. So in here, I want very first thing is adjacency list. So let us create the adjacency list. So what is the adjacency list? I'll say ADJ list right here. Okay, I'll say ADJ list right here. How do we create adjacency list? We create it like this. We note down all the nodes and we note down all the nodes like this, and we write all its neighbors right here. So in this case, who is the neighbor of 0? 0's neighbor is 2 and 4. So I'll say 2 comma 4. Who is the neighbor of 1? 1 neighbor is 2 and 3. So 2 and 3. Who is the neighbor of 2? 0, 1 and 3. So 0, 1 and 3. Who is the neighbor of 3? The neighbor of 3 is 1, 2 and 4. So 1, 2 and 4. Who is the neighbor of 4? The neighbor of 4 is 0 and 3. So I noted down 0 and 3. 0 and 3. Comma 3. So guys, this is our adjacency list already ready now. Our adjacency list is now ready. We can now start with creation of the queue. Let me say that this is our queue. Now it looks like a stack, but it is not a stack, it is a queue. Guys, it is okay. Think about that, it is a queue. Queue. Why we want to use queue data structure? Why? Because queue data structure has the concept of first in, first out. Remember, if you don't remember that, I have created the session again on the queue data structure. That is on, I guess, session number, it is under 10 only, I guess. So go ahead and watch that. You can watch the thumbnail. In the thumbnail, I have already mentioned everything. We have created the queue. Why we want to create the queue? This is our queue, Q-U-E-U-E. Okay. Why we want to create the queue? Because I want the first in, first out concept. In a moment, you will get to know why I need queue. Alright guys, it is okay. Let us see why I need the queue later on. Okay. So here I have the queue. Now I need a visited vector. So visited vector, this is our visited vector, where now I will be noting down all the nodes just like adjacency list, but by default I will be putting false into all our nodes. Okay. Why so? Because it says that it is not visited yet, so it is false. Similarly 1, 2, 3 and here we go 4. False, 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 false. That means the type of the visited vector is going to be Boolean here in this case. Understood? Because we are taking true and false values. I hope so that this is very much clear. And we have our answer vector right here. We have our answer vector right here. We will be giving the answers in right here. I hope so that this is very much clear to all of you guys. Okay. If you have any doubts, please post it in the live chat. I can see right there. I can see the live chat. Okay guys, let us see. Now, number one rule while you are traversing the graph in BFS, number one rule. The rule is you can start from anywhere. This is not a rule, but because in graphs we don't have a root. Unlike trees, we don't have a root here, right? So we don't have any starting index. We don't have any starting point. So you can start from anywhere you want and you can go in any direction as you want. Direction will be automatically taken with the algorithm, but there is no root. So either you can start from 0, or maybe you can start from 2. It is up to you, totally up to you. You see, whenever you start a particular traversal of the graph from anywhere, let's say you started from 0, the answer will be different. If you start from 2, that particular answer will be different. If you start from 1, then the answer will be different, because of course from one node to another node you are traversing, but you are traversing in different directions, moving to different nodes from different directions. So of course the answer will be different. So don't think that my answer is not matching with your answer, so your answer is wrong or my answer is wrong. No, answer is going to be correct if our process is correct. Trust the process and you will get the right answer. Other than that, whenever you start with different points, you will definitely get a different kind of answer. This is how BFS or DFS, in fact the traversal concept works in graph. I hope so that you guys are getting what I am trying to say. Alright guys, so in here now we want to do BFS. Let us continue here. So here we have, let us say I am starting as usual from 0. Starting index, as we have already been starting from 0, always we are going to start from 0. You can start from 1 or any particular place, that is up to you. Okay. Now, what is the first step? Before you start any iteration, we will be using a loop, a while loop, to iterate over whole thing, and we will be doing it until all the nodes are, visited. Is that clear? So initially what I'll do is I'll push the first node, whichever is the first node you want to start, you push it and keep it right there in the queue. Right in the queue you will push that particular element, push that particular node, and you will wait. Understood? Before you start the iteration, your while loop will start from, we are going to use a while loop of course here. Understood? So while loop will start from where? While loop will start from by first taking out the front. You know this front concept, right? That in queues data structure we have front and back. How? Because of the concept of first in and first out, we get two variables to manage in queues data structure, that is front and back. So in front, the frontmost element is gonna be currently right now 0, the very first element which we have pushed into the queue. This is going to be there in the beginning before you start the iteration, and the iteration will go till when? The iteration will go till while queue dot empty is not, while not of queue dot empty, while not of queue dot empty, while not of queue. Let us say our queue name is queue dot empty, while not of queue dot empty. Understood? Till then it will keep on running, because ultimately as soon as the queue gets empty, our job is done. We have traversed. Understood? So let us try to understand how this is gonna work. Okay. So I'll rub this off for now. I'll directly show this into the code. You will understand from there. Okay. I don't want to confuse anybody right now. Guys, understand the logic first. How you will traverse, because these kind of programs require you to first understand the logic. If you have understood the logic in terms of story, you will be able to write the program for it very easily. Understood? Let us start. Initially everything is set up, we are starting from 0. Actually we are standing on 0 because that is our starting point. Wherever you are standing, that particular node has to be pushed into the queue. Understood this? I hope so that this is very much clear to all of you. Now the first step. I'll write the steps here. Okay. I hope so that it is visible and there's no issue in seeing the steps. Okay. Yeah, I'll move it a little bit onto the left hand side so that you can easily see the steps also. Yeah, here I'm gonna write the steps. Okay. Step 1, take out the front. Find out front, number 1. Who is at the front in the queue? In the front we have 0. You have 0. You took the front, you got the 0. First step is take out the front. Second step is you can just pop the front, pop it out. So we popped it out, we deleted this. Then the third step is print it in the answer, print it in the answer, print it in the answer, 0. Let's print it with green. Okay. Okay. So answer got, our first element got printed already. Okay. When you do this, mark 0 as visited. So this is being now visited already and this is marked as true. Okay. False became true on 0th index in the visited vector. Okay guys. And then what you will do, go to its adjacency list, number 4, adjacency list, go to its adjacency list, go to its adjacency list. So 0's adjacency list says push 2 and 4, 2 and 4. You will check, is 2 visited? No, 2 is not visited. So you push that 2 and then you check 4, is 4 not visited? No, 4 is not visited. So you push 4 also. Understand my point? And as soon as you add any of the elements, as soon as you push any of the elements into the queue, you mark them as visited. So 2 is done, 2 is marked as visited. 4 is done, 4 is marked as visited. This way you will be able to keep a track of what nodes, which nodes are visited and which nodes are not visited yet, like that. Understood? Now, the concept of BFS says breadth first search. Breadth means breadth wise. So in every single time, whenever you push or whenever you go to anyone's adjacency list, you have to push the whole list together into the queue. But before you do that, make sure you check that those elements are not visited. If they are not visited, then you have to push them. If they are visited already, then you have to skip those elements. So this thing you need to remember. I hope so that this is very much clear to all of you guys. Okay, understood? So in this case, this is okay. Okay, now we went to 0, this is done. Now repeat this concept, repeat this step again, starting from the beginning. Acha, fifth step was to push neighbors, Now it again started. Okay, what is the first step? Take out the front. Front is 2. Front is 2. Pop it out. Print it in the answer. Print it in the answer 2. Okay. Then go to its adjacency and it is already visited. Go to its adjacency list right here and now you check 0, 1 and 3 it says. Push 0, 1 and 3 it says. You will check, is 0 visited? Yes, visited. Skip it. Is 1 visited? No, it is not visited. So now you push that 1 right in the queue and mark 1 as visited, say true. Okay. And then this is also done. Well, this is also done, this is also done. Okay. Then check next one, 3. Is 3 visited? No, 3 was not visited. So push that 3 right here and mark 3 also as visited. Understood? Now your all the elements are pushed. All the elements are pushed. All the neighbors of 2 are pushed. Understood this? So here what happens next is go back and take out the next front. Who is the next front? 4 is the next front. Pop it out. Print it in the answer. Pop it out. Print it in the answer. Go check its adjacency list. In 4 adjacency list, you see 0 and 3. You see 0 and 3. Now 0 is also visited, 3 is also visited because you see from the visited array all the elements are visited. So there is no point of pushing any elements again further. Making sure that you are not visiting the node which is already visited once before. This way you can avoid overlapping of the elements while you are visiting and traversing. As soon as you do that, you skip all the elements and then you go back and do the same thing again where you check the next front. The next front is going to be 1. Pop it out, print it in the answer, write like this and go to its adjacency list. Go to its adjacency list, check 2 and 3 are already visited, no point of pushing them again into the queue. Move on. Take out the next element. Next front is 3. pop it out, print it out, go to its adjacency list, and you see that 1, 2 and 4 are already visited. So you don't visit them again, and you see right here guys, the queue is empty. As soon as the queue empty, it gets over, and guys, this is the traversal answer 02413. So you see how the traversal is being made, 02413. This is breadth first search. I hope so that this is absolutely clear to all of you guys, and it is being cut like this. So like this we are moving breadth wise, right? It is breadth wise, so we are doing it breadth wise. There you go. I hope so that this is very much clear to all of you. Adjacency list, queues visited, answer vector you need in order to do the job. So with the queue you will get the front. Every time you will put you will take out the front, you will do the job of updating that, and will print it in the answer, and hence you will do the job again and again like this, and so on until your while loop stops. And when this while loop will stop as soon as the queue gets empty. And guys, you already saw that queue is now empty, and when the queue is empty, your answer will be published, it is pushed. Let us see the code for it. Very simple code guys. Now here in this code, what we have done here is that in the main function we have taken the number of edges and vertices. So first one is vertices and the second one is edges. Okay, so we are creating the adjacency list right here in the main. And if you don't know how we have created the adjacency list, just check out our previous video where I have explained you about how adjacency lists are created. Alright, and there you will find how adjacency lists are created. I hope so that this is very much clear. We are reading and constructing the adjacency list, and here you see that this is how we have already seen this process already in our previous video. So I have already explained you how this adjacency list is created, how the adjacency list is worked around with. Understood? Then we have our result, our answer. For that we are calling this function called as BFS Traversal. We have already written this right here. This BFS Traversal is returning the answer vector, remember? So the return type of this function is vector of type int. It is going to return the whole vector of type integer. Well, I hope so that this is absolutely clear to all of you guys. Yes or no? Yes. Kirtana MG, hello sir, your sessions are very helpful. Thank you Kirtana. I hope so that you are able to understand whatever I am speaking, whatever I am explaining. Because of your subscribers like you, I get motivated to create more videos like this, which pushes me into this creating this kind of content in front of you guys. Thank you so much again guys. Let us continue now. So we have created a function here called as BFS Traversal, which is taking up the the number of vertices, and here it is taking up the adjacency list. Okay, the adjacency list. Here you can see it is taking up the number of vertices and the adjacency list, and it is going to return us that answer vector. I hope so that this is very much clear. Now we'll create the visited vector. This is the visited vector. It is of type boolean. So by default it is of size n. So number of vertices which we have taken into the parameter, that will be taken right here, and visited array size will become that particular number of nodes. I hope so that you understood this really well. Okay, then false I have taken up as a normal default value. So I have taken false as the default value. I hope so that this is very much clear. So our visited vector is ready with all the values false, 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 and all the nodes are set to properly false. That means none of the nodes are traversed. Traversal order, this is the answer vector guys. Vector of type in traversal order. This will actually be returned at the end from this function. This function is being returned at the end. Okay, so this is the traversal order vector which I have created, and then here we have created our queue. Guys, you already have understood what are queues and how they work. I hope so that this is very much clear, guys. Okay. So what all things we have covered? We have already created the adjacency list in the main function down there. We have created the vector for visited vector. Then we have created the answer vector, and then last we have created the queue. Our requirement is over. We start by pushing our first node. Whichever is the first node, that is going to be pushed, and it is marked as visited already. It is marked as visited already. So first node is already visited because you are standing onto that node, right? I hope so that this is very much clear. And I have explained you this thing. While queue doesn't become empty, this while loop will start, keep on running. So while queue not of queue dot empty, we will take the frontmost element, store it into the current variable. Why? Because later on we need to go into its adjacency list. So if I delete it right now, how will I go into its adjacency list and find out its neighbors that needs to be pushed, right? I hope so that this is very much clear what I am trying to say. Remember this, that if we directly pop out the front, what will happen? I will not be able to push all its neighbors into the queue, right? So for that reason, I will make a copy of that into int current here, and then I will say q dot pop. So it will be popped, deleted. First 0 is deleted, okay. Then we will push that into the answer vector. I hope so that this is very much clear. After going into the answer vector, now you see this very carefully. This is the main logic here, guys. I am going to the neighbor of the adjacency list of the current. So I am saying that this is a for each loop. I have already explained you what is for each loop. If you have not understood that, you can watch other videos also, where I have also explained. In the previous, I guess so that I have explained you this in trees concept, I guess. Yes, I guess so, trees concept, yes, we have done for each loop. Okay, this is for each loop. This is the iterator neighbor, you can say I, it is neighbor here, where neighbor will go into the adjacency list of the current. Current was the element of which we have made the backup of, and it will go into the adjacency list of current. Where is this adjacency list is coming from? Adjacency list is coming from here, where we have passed the whole adjacency list. We are doing call by reference and pass. Now you don't have to write const, it is okay, that is fine. Just ignore that const, but it will work fine. Okay. And here the neighbor, this iterator neighbor will go into the adjacency list of the current, and it will check if it is the neighbor is not visited in the visited array, is the visited vector. If the visited vector of neighbor is not visited, then you will mark it as visited of neighbor, visited of that particular index will mark. So in the visited array, mark that index as true and then push that element into the neighbor. That will push it into the queue. Q dot push that particular neighbor. I hope so that this is very much clear to all of you guys. This concept is clear. If I am way too fast, please tell me. You can slow down this video. YouTube has the facility of slowing down the video also. But I hope so that this is very much clear. If you have any doubts, please do let me know. This is your BFS Traversal. And it will keep on going until the queue doesn't become empty. As soon as the queue becomes empty, you see that traversal order, that answer vector is returned, and what happens next? It directly goes here and it is now iterated and printed. Very simple. Understood this, guys? Let us try to run this code and check if our traversal is correct or not. So it will first ask the number of nodes and number of edges. So how many number of nodes and edges we had? According to this, we had 1, 2, 3, 4, 5 nodes, and how many is 1, 2, 3, 4, 5, 6 edges, correct? 5, 6. Now we will start pushing all our edges. So let's see, the first edge is 0 to 4, so 0 to 4. Then the second edge is 0 to 2, 0 to 2, okay. The third edge is 4 to 3, 4 to 3, okay. The next edge is 2 to 3. Then the next edge is 2 to 1, and the last edge is 1 to 3. So our result is 0, 4, 2, 3, 1, 0, 2, 4, 3, 1, 0, 2, 4, 3, 1. Okay, guys, you see our answer is coming as 0, 2, 04231 04231 it is coming. Why? Because it is taking in the ascending order, but the answer is absolutely correct. No issues, our program works absolutely fine. I told you what happened here is, for us it is traveling like in one direction like this, but in the code it is traveling from, it slashed it like 3 and 1, but it is correct. It is still correct. It is doing 0 to 4 and then from here it came back like this and 3 and 1. Answer is absolutely correct. There is no issue in the answer, guys. This is your breadth first search traversal in the graph. I hope so that this is absolutely clear to everyone. If you have any doubts, please do let me know. I have a screen in front of me showing your comments. So please, if you have any doubts, please ask me. I'm going to start the doubt session now. We'll start up the doubt session and then we'll finish up. If you have any doubts, please do ask me. If you don't have any, I'll stop this stream and I'll come back again live tomorrow at the same time. Let's talk about that. I hope so that this BFS Traversal is very much clear to all of you guys. This BFS Traversal is very much clear to all of you guys. No comments. I believe that everyone understood. If you missed this live session, guys, it's okay. We have recorded it and we are going to put it into a playlist for other users, for the later, for the viewers who comes late and later on they follow this series. So don't worry, this live session is already recorded and it will be put into the playlist for this. And I know, guys, you guys were all complaining about, sir, the session number 32 is not working. Yes, I know session number 32 is not working. I need to re-record it. It was all about vectors and maps, but the main concept of vectors was already taught in session number 31. The two-dimensional vectors were covered into that video. So I will cover that again. Don't worry about that, guys. Give me some time. I was not well, so that was the reason I was not able to come, and that is the thing. Sachit, sir, 1 minute. Yes, Sachit. Yes, I'm waiting. We are into doubt session right now. Any doubts, you can ask me. We have some time. When I went to outstation, when I was outstation, at that time I was not able to come live properly, and at that time my health was also not really good. At that time I recorded that session number 32, and the unfortunate thing happened that because of the bad internet connection, it was not uploaded properly and that session was corrupted. So now we had to re-record that session, and yeah, we will do it very soon. By the end of the next week, guys, I believe that I will be completing the whole data structures playlist. By the way, I think so we will be able to finish it by the end of the next week. Next week ending, I believe so that this placement series 95 to 98% will be covered. Only one thing will be left, that is going to be dynamic programming. I know people were asking about dynamic programming. Sir, will you do dynamic programming or not? So I am planning to do it as well. So yes, I will be doing dynamic programming. Later on, once all our live sessions are over properly, I will again come live for, I will start another live session, live streaming sessions for problem solving, where we will solve all the company related problems. Okay. Alright. Sir, one thing please check. Okay, knapsack of Abdul Bari, how he explains with the program and example side by side. Oh, for that I have to check its video. Maybe let us do it tomorrow. In tomorrow's class I'll do it. I'll check up the video and I will do the example, how he explains with the program and example side by side. Sir, please check knapsack of Abdul Bari. Okay. Recommend to my friend too, sir. Okay. Yes. Don't worry, Sachit. We will do it. Don't worry. Let us. Yes, Sachit. We will do it. But I have to watch that video. For watching that video, I need some time. I have not watched that video yet. So, give me some time. By tomorrow, same time, I'll be coming. Yes, sir. Thank you. Yes, I'll be doing it. Don't worry. Tomorrow, I'll come. I'll try to finish up what we left here, and at the end of the session, I'll do this Abdul Bari knapsack problem. Knapsack problem. Yes, how he explained the program and example side by side. Yes, I will do it. Definitely, I'll do it. No problem. Sachit. Yes, Sachit. Anybody, any doubts? Yes, will surely recommend your channel for sure. Yes. I believe so that you have come to our previous live sessions also with the same issue, right? I believe so, and we were not able to, rectify it that time because we were busy in doing something else. I believe so, that was the case. But it's okay. We will cover it. I'll take a note of it. Yes, Sachit. Yes, I will do it. Alright, guys. Yes, I will do it. Alright, guys. I hope so that you have understood today's video very well. Today's live session was really good. And we have covered the BFS Traversal. The code I can give you in the comment section of this live session. Notes, the same link for this Blackboard file. I'll convert this whole Blackboard file into PDF. Yes, I will check it. Yeah, I'll convert this whole file into PDF and I'll put the link of this file into the description below. All the notes will be provided there, guys. And don't forget to like, share and subscribe to my channel, guys. And don't forget to press the bell icon also so that you won't miss any future updates. Share this live stream to as many people as possible so that those people who are in need of studying DSA should also get it. And share this live stream. Thank you guys so much for watching. Thanks for all the love and support that you guys are showing us. It really motivates us to create more such content like this, and it's a very very pleasant job to do while we are creating these kind of videos, solving these kind of problems, interview related problems. We'll definitely be doing that. Yes. Any other doubts or issues, please do let me know in the comment section below. And yeah, that's it. Thank you guys so much for watching. I'll be ending up this live stream now. Time is over, and I will see you guys tomorrow again, back at same time, 7 o'clock in the evening, Indian Standard Time, 7 p.m. Indian Standard Time. I'm repeating this, 7 p.m. Indian Standard Time. I will be coming up back live onto this same channel, YouTube, in Coders Arcade. I'll be doing depth first search I'll be doing, and I will be I'll be covering that problem also. Just give me some time, Sachit, and I'll check that, and I'll definitely will come back with the answer. That will be live session number 37, guys. Alright. Thank you guys so much for watching. This was live session 36. This is Dashank David signing off, and I will see you guys again back tomorrow. And thank you guys again for watching. Let me just end up this live stream very quickly so that this is done. Okay, guys, I'm going to stop this live stream. Take care. I'll see you again. Take care of your health. My health was not good, so take care of your health. See you again tomorrow. Take care. Bye-bye. Stay safe. Happy learning. Bye-bye.